Hello, Richie Owens here, and I'm going to take you through some economics. We're going to start off with first big topic in here, which is macroeconomics and topics in demand and supply analysis. And the first LOS we're going to hit is the world of elasticity. You'll see from the LOS, it is calculate, interpret, and describe. So you've got the full hit here. The examiner wants you to be able to talk to him about elasticity, talk about the implications of a given elasticity, and as we'll see in a couple of examples, calculate it as well. A few different types, so let's kick off with really the granddaddy of them all, own price elasticity of demand, often written as PED. You can see the calculation top right. We have the percentage change in quantity over the percentage change in price. What do we mean by that? Well, what we're looking at quite simply is what happens to the amount of a good that is demanded given a change in the price. So what's the change in the quantity actually sold if we change the price of the good? Now, if you sit back and think about this logically, you will come up with the correct answer in terms of whether this should be positive or negative. Just ask yourself quite simply, if the price goes up, what is likely to happen to the quantity that we sell? And the answer is, as the price goes up, you would expect the quantity you sell to go down. And that certainly is the case for a normal good. However, we can get more excitable than that. We're going to break this elasticity down into elastic and inelastic demand. So start with elastic. What does that say? Well, if it's elastic demand, the percentage increase in price leads to a larger percentage decrease in quantity. So for example, if we take our, let's say, soft drinks and we bump up the price by 10%, we lose more than 10% of our sales. So price goes up by 10%, let's say quantity drops by 15%. We would say that demand is elastic, the percentage change in quantity greater than price. Now, how do we refer to that? Be careful here. We tend to refer to the price elasticity of demand in absolute terms. Absolute terms means we ignore the negative. We know the price elasticity of demand is going to be negative in almost all cases. We've just discussed that. But if we talk about it in absolute terms, and you can see here on the slide, these straight brackets here, these mean we are talking in absolute terms. So when you ever see those straight brackets, ignore the negative. So we will say we have elastic demand if our price elasticity of demand in absolute terms is greater than 1. Really what we mean, ignoring those absolute terms, is it's less than -1. But that's a pain to keep having to say. So we'll talk about absolute terms, it's greater than 1. Inelastic should now be fairly obvious. Inelastic, it is in absolute terms less than 1. So a percentage increase in price leads to a smaller percentage decrease in quantity demanded. So now we bump our price up by 10% and we lose only, let's say, 5% of our sales. So all you need to do really in terms of the interpretation here is absolutely lodge in your mind absolute terms of 1. If your PED is greater than 1, it's elastic. Less than 1, we are talking inelastic. Could you be asked to calculate this? Well, absolutely. And we'll go on and see some more interesting and detailed examples of that in a moment. But in a very straightforward question, no reason the examiner doesn't just give you some percentages and get you immediately to interpret that as elastic or inelastic. Okay, next up, extreme examples. Economists love to talk extreme examples. There are very few situations where either would happen, but it's worth just explaining it to the examiner because, again, it's in the readings. So starting on the left here with perfectly elastic demand. First thing to say, if you've been through the base material, you should see you have your classic diagrams here with price on the vertical axis and quantity on the horizontal. So we're looking here at what changes in terms of the quantity for a change in price. If it's perfectly elastic, then look what happens. The demand is absolutely horizontal. Do you ever see that? Well, we're actually going to see an example of that when we get to market structures. So let's just hold fire on what that means. But let's go to the right-hand side with perfectly inelastic. Here you have a vertical demand curve. The point being here, the same quantity is sold at every single price. So you can change the price to whatever you like, and the exact same quantity is sold. Very extreme, very unlikely. The classic example given is a life-saving drug. If you require 1 tablet a day to survive, then if it's very cheap, you're only going to buy 1 because you don't need any more. But if it's very expensive, you still have to buy 1. Hence, perfectly inelastic. So recognize a couple of things. If it's perfectly elastic, it's horizontal. Perfectly inelastic, it is vertical. And then a nice little add-on point at the bottom there. Only in these extreme examples is the price elasticity of demand constant along the entire curve. Could be a nice little trip question, because we often show these demand curves as straight lines. Even if they are downward sloping, we show it as a straight line. Just because it's a straight line does not mean PED is constant all along it. That's only the case here, where you have perfectly elastic or perfectly inelastic curves. Okay, good stuff. Next up, factors that influence this elasticity of demand. There are 3 of them. Whenever you see a list of 3 things in this syllabus, given the nature of the exam, you should get excited. 3 things. Your questions are objective test questions with 3 answers. So you could be given these 3. One of them would be slightly wrong in the exam. You'd be asked to pick which one is least likely. So any list of 3 definitions is gold dust for you. So 3 of them: substitutes, proportion of income, and time. I think they're fairly straightforward if you just think about them intuitively. Let's start with substitutes, availability and closeness. Well, the more substitutes there are available, the more elastic demand will be. So if you're looking at soft drinks, there are lots and lots and lots of other soft drink brands available. If one puts their price up, why would you stick with drinking Coke when you could switch to Pepsi? I know there are taste differences. There are some people very passionate about it. But if there are lots of substitutes available, an increase in price is likely to see a big drop in demand because people can look elsewhere. On the other hand, if you are the only supplier supplying that good, you have a lot more flexibility to put your price up. There's nowhere else for people to go. So the more substitutes there are, the more elastic your demand will be. Secondly, proportion of income spent on the item. The larger the proportion of income you spend, the more elastic your demand is because you notice it. If it's a huge part of your income, you are much more sensitive to price changes. Hence, you're more elastic. And finally, a kind of golden rule of economics: the time elapsed since the previous price change. The longer that time is, the more elastic the response will be. So what we're saying here, as a kind of golden rule, as I say, in the long run, responses are always more elastic. Think of the price of gas going up. First thing that happens when the price of gas goes up is everybody complains about it. But in the short term, you can't really change your routine. You can't change the use of your car, so you just have to get on with it. But in the longer term, you may then start to organize carpools. You may buy a more efficient car. You may start to use public transport. So you try and think of more creative ways around it in the long run. So in the short run, not that elastic. As time passes, responses get more and more elastic. Okay, solid list. Next up, looking at elasticity on a straight line demand curve. We've mentioned this once already, but worth repeating. Just because that demand curve is a straight line does not mean elasticity is constant along it. Why? Well, because we are not looking at the absolute change in quantity and price here. We are looking at the percentage change. And what you'll see, point A towards the left, when you're at this top end of the curve and the price up there is very high, low quantity, high price, you tend to get very high elasticity. So very sensitive changes to price. When you're down here and you've got a very low price but a high quantity, you tend to get low elasticity. Now, they're the extremes. As you come towards the middle, you will reach a point where you have unitary elasticity. That's where it's equal to 1. In absolute terms equal to 1, we know it's -1. Now, what does that mean for the supplier? What should you do as a supplier? Well, If you're at the top end of the curve and you've got high elasticity, think what that means. Slight change in price, big change in quantity. So for a slight change in price, big change in quantity, what do you want to do with your price? Well, drop it a little bit and pick up a huge amount of sales. On the other hand, low elasticity. Well, if I've got very low elasticity, big change in price, I don't lose too many sales. So I want to increase my price. And what you'll do is head towards this unitary elasticity. So not constant, and you may be asked to tell the examiner as a supplier where you are on the curve dictates what you should do with your prices. You're looking to move towards unitary elasticity. Now, implications of that, well, where can we maximize our revenue? Well, for the reasons we've just discussed on the diagram, you want to move towards an elasticity of -1, in absolute terms, 1. At that point, you will maximize your revenue. Be careful here in the world of economics. Revenue is different to profit. We are maximizing revenue here. For a lot of the rest of microeconomics, we'll talk about maximizing profit. This is just revenue. Because if we are in the inelastic range as discussed, increase your price, revenue goes up. You don't lose too many sales. In the elastic range, well, price increases decrease total revenue. What you want to do if it's elastic is drop it and pick up a huge amount of sales. So some good points, perhaps not kind of the mainstream part of the syllabus, so it's good to pick up this interpretation because a lot of candidates will just think, if I can calculate elasticity, I'm done. There's much more to it than that. All right, here are the calculations. My view is always in economics, anytime you see numbers, people jump all over it. There's an awful lot of economics in this syllabus to get through. Most of it is discussion. So people always wake up and come alive when they see numbers and therefore get good at them. So yes, absolutely get good at the numbers to keep pace with the average candidate, but make sure you can do that earlier discussion to get ahead of them. But this is how we can calculate it. A little bit of math. Everyone loves a little bit of math. Percentage change in quantity over percentage change in price, we already know. So we've talked about that. We know how it works to get inelastic elastic. But with a little bit of math, that means we are looking at the percentage change in quantity over percentage change in price, which we can write as the change in quantity over the current quantity, divided by the change in price over the current price. You don't need to learn that. It's just there for you if you like math, because if you like math, you can work out what's happening. So if you can see what the calculation is doing, all you need to do is get to this final version. You can rearrange that middle version to get P0 over Q0, current price, current quantity, multiplied by the change in quantity over the change in price. Now, as long as we have the demand function, we're going to be very easily able to calculate this elasticity. All we'll need is the current price and the current quantity. So, as long as they're given, we're in business. Then the change in quantity given the change in price, well, if we have this demand function, which is quantity as a function of price, it's going to be the equation of a straight line. So quantity will be A, some sort of intercept, plus B times price. B is the slope coefficient of price. In other words, if I change price by $1, quantity will change by B times 1. So the change in quantity given a $1 change in price is B. Therefore, B is the change in quantity over the change in price. Now that's the explanation. What you need to do is just learn that formula and be able to apply it. If they give me the current price, current quantity, and I have the slope coefficient for price from that function, then I can calculate elasticity at any point. So let's try and put it into practice. So here is a classic demand function for gasoline. It is the quantity demanded, 138,500 minus 12,500 times the price. So we have the demand function. The demand function is quantity demanded as a function of price. So as soon as you see that, what should jump salmon-like to the forefront of your mind is here is the slope coefficient of price, 12,500. So that's going to help. Now all I need is the current quantity and current price, and I'm in. What do they give me? Well, calculate the price elasticity of demand at a price of $3. So we have the current price. We have the slope coefficient. What we're missing is the current quantity. Well, okay, I can calculate the current quantity if I just put my price into the demand function. So let's move on and do that. So from the question, the price is 3. Put the price of 3 into that demand function and you'll calculate a quantity of 101,000. Pretty straightforward. And we already know the change in price over the change in quantity is minus 12,500. Why? It was the slope coefficient in that demand function. So how do I calculate my price elasticity? Well, current price given in the question. There it is, $3. Current quantity, we put $3 into the demand function and it spat out 101. Multiplied by that slope coefficient of minus 12.5. That gives us minus 0.37. There endeth the calculation, but make sure you can go on and do the interpretation. In absolute terms, minus 0.37 is less than 1. Hence, we'd say demand is inelastic. Classic question, I would say that as a calculation is pretty straight down the middle, and you want to be fairly comfortable trying to do that. Because it could, as we're about to see, get a little bit more exciting. Moving on. A couple of other elasticities. These are just good fun. If you get the basics of price elasticity of demand, then cross price and income aren't too bad at all. Cross price, first of all, the formula is almost identical. The only difference is we are looking at 2 different goods. So classic example at the top, we've got the price of coffee going up and the demand for tea going up. So 2 different goods. We have the same formula, percentage change in quantity over percentage change in price. But it's the percentage change in quantity of tea divided by the percentage change in price of coffee. That gives us, in this example, 16,6, 11,1, that gives us 0.67. Now, we're not overly excited this time about whether that's greater than or less than 1. What we're excited about here with cross price is whether it's positive or negative. Here you can see it came to a positive number. What does that mean? Well, the goods are substitutes. Well, does that make sense? Yes, the price of coffee went up. More people started drinking tea. That means tea, in this case, is a substitute for coffee. People turned away from coffee and drank tea instead. The bottom half of the slide, pizza and cola, the opposite. Price of pizza goes up. A huge amount of cola is sold with pizza deliveries. So if the price of pizza goes up, fewer people are ordering pizza. The demand for cola drops. We get a negative cross-price elasticity. Hence, those goods are complements. Selling pizza helps sales of cola. So we've got own price, we've got cross price. Finally, moving on, we have the world of income elasticity of demand. This is the sensitivity of quantity demanded to changes in the level of income. Not price, but the level of your income. So what happens to the percentage quantity demanded given a change in how much you've got to spend? Well, once again, we're interested here to see if it's positive or negative. And we break it down into normal goods and inferior goods. For a normal good, the more you earn, the more you demand. So you'll get a positive income elasticity. But there are such things as inferior goods. Examples here taken from the CFA syllabus, bus travel and rice. So you may be offended here if you're a big fan of either of those two, but let's think bus travel. The idea is, at the moment, as a candidate for the CFA program, you have to travel by bus. But once you get your CFA charter, obviously you're going to make millions and millions and millions of dollars, and you'll have your own chauffeur, and you'll never need to take a bus again. So as you earn more, the amount of bus travel you will buy will drop. That will give you a negative income elasticity. So inferior goods have negative income elasticity. That's the entire suite of elasticities. All we need to do to finish off is just a couple of extra examples to show how it could get a little bit more entertaining. So moving on, we have this example, which brings in both income and cross-price elasticity. Hopefully you can see what's happening here. If you saw the earlier example, we're just extending it. Earlier we said the quantity of gas demanded was A plus B times the price of gas. Now we say plus, it's always going to be a negative coefficient for normal goods. But we're now adding in other factors. Not only does the price of gas affect the demand for gas, but also the level of income, also the price of bus travel, and the price of buying cars. So there's a price of this product, there's our income level, and there's a price of other products. So the demand function can start to get quite long-winded. Don't think of it as more complicated, it's just longer. Okay, so we have that demand function. What do we need to start answering questions? Well, the examiner is going to start giving us information. So if we click on and see the question with data in it, we're told using the demand function given, assuming an average price for cars of $22,000, income of $40,000, bus travel of $25, and a price of $3, let's get the income elasticity and the cross-price elasticity of gasoline with respect to the price of bus travel. This takes a while to work through, but once you get through it, it will start to become a very mechanical process. So first steps, put all the information we have into that demand function. And that's what we've done on the next slide. So you can see the quantity demanded of gas was 15 minus 3 times the price of gas, which we've slotted in, plus 0.2 times our income level. Let's just leave that for the moment. Plus 0.11 times the price of bus travel, which we put in, minus 0.008 times the price of cars, which we've also slotted in. So the quantity of gas demanded shortens down to that. Do the math, you get 8.6 plus 0.02 times the level of income. Now we've just highlighted that because now you can see the slope coefficient for income, 0.02. There is the slope coefficient for income. So if we're going to calculate the income elasticity of demand, it's going to be our current income level, our current quantity demanded, times the change in income, change in quantity, which is the slope coefficient. That's that trick, that little calculation we talked about earlier. So we have all the information we need. Our current income level is 40,000. There it is. What is the quantity demanded at that income level? Well, let's just finish off the calculation. 8.6 plus 0.02 times that 40 gives us 9.4. There is our current quantity demanded. Multiplied by 0.02, the slope coefficient, change of income given change in price. Multiply that out and you get 0.085. Could that be asked as a calculation? Well, yes, it could. It's not the most likely thing in the world. It's quite long. And people say, well, I'm never going to get this done in 90 seconds, but things balance out in the exam, as I always say. This might be a slightly longer question. There'll be other shorter ones. But if I was you, I'd try and practice a few of these little and often, because candidates who don't like econ often focus on just making sure they can get those numbers right. Okay, one more, calculate cross-price elasticity. So we did the income. What about cross-price for bus travel? Exactly the same calculation. So once again, put all the data that we have into the equation. This time, let's leave out the price of bus travel. And that equation slims down to this, 6.6 plus 0.11 times the price of bus travel. Well, that means here, 0.11 is our slope coefficient. So that's going to go into our final answer. We need the current price of bus travel. It's given to us. It's 25. And we slot that in to work out the quantity of gas demanded. Well, at that price, it's 9.35. Once again, multiply it out, and you'll get 0.294. If you practice one of those every 2 weeks until the exam, it will be absolutely permanent in your brain. Obviously, you've got hundreds and thousands of things to keep practicing. I know that's an issue, but if you could just do one of these every 2 weeks, it would sit nicely in your head.